Most recently, I'm working on a feature called Fault Tolerance. And fault tolerance actually has a pretty long history because we had ideas about it quite a while ago, and we said, oh, seems like it's possible, where we could run two virtual machines essentially in lockstep, and they're doing exactly the same execution, so that if one of the hardware of one of the virtual machines fails, then the other virtual machine can immediately take over with no loss of state and no loss of connections and so forth. So you basically can survive a hardware failure. A couple of my colleagues started thinking about how can we actually do this, and they started working on the fundamental technology, which we call now vLockstep, which is the technology to keep two virtual machines in sync. Essentially what we're doing is we're recording non-deterministic events in a virtual machine, and since we have complete control of the virtual machine, there's a software layer into the virtual machine, we know exactly when there are these events which are non-deterministic, which means they may not happen the same way the next time around you execute. And so those events are what we send over what we call the logging NIC to the other side, to the secondary. And so we have the technology where we record those events on what we call the primary virtual machine, send it across the logging NIC, and then we have a technology on the secondary to replay those events. So while you're running deterministically, you're not really replaying anything, you're just running. So in the end, what you have is the two virtual machines are doing the exact same execution always. Exact same memory, exact same execution, exact same I/O, and so forth. The other thing that design choice we made with fault tolerance was to use shared storage. And that kind of fits in with the vSphere model, which is if you have shared storage, it becomes much easier to share all the computing resources. So after a failure, the secondary VM will take over. We will actually go around and find a new host to run a new secondary VM, and then we'll use vMotion again to create the new secondary as a clone of the primary and get it into lockstep mode. And all of that is somewhat enabled by the fact that we have shared storage, so you're not copying disks around and so forth. For the customer, it's really just as if nothing happened. The virtual machine is still running. It's another choice in the range of availability. So for some applications, you would just use HA and say, if a crash happens, I can restart it, and it will restart in 30 seconds, and that's okay. And for some applications where you really don't want to have interruption, where the clients are very important or the connections are very important, then you might use fault tolerance so that you don't even have that 30-second interruption. It's not a lot of bandwidth except for the network packets that are coming in. So it's it's a fairly small amount of bandwidth when things are not very active. So that's actually quite nice. There are possibilities that we could look to the future, like long-distance fault tolerance or things like that. We want to keep the flexibility of vSphere and VI, but there's also since this is fault tolerance, we want to make sure that the fault tolerant VMs get enough resources. One of the things you might do is spread out the fault tolerant VMs, both the primaries and secondaries, among all your hosts, rather than keeping them all the fault tolerant VMs all on only two hosts, because then you're going to be using a lot of bandwidth on the logging NIC that's between those two hosts. So we want to have the flexibility, and in fact we support the flexibility. We allow vMotion of a fault-tolerant primary or secondary, so you can move them around. A cluster can have both fault-tolerant VMs and non-fault-tolerant VMs. You can enable fault tolerance at any time as long as you have resources. You have the CPU cycles, CPU resources that you need on the secondary host. The fault tolerance project has been really great, I think, for a number of reasons. One is, it's been a hard project, and it's actually been over quite a number of years to kind of develop the technology and prove that it's actually not only doable, but actually practical with reasonable performance. And it's been just great to work with a whole bunch of really smart people, and also working at many different levels. We've had to work all the way from the hypervisor level to the user level, all the way to the virtual center and so forth, and getting all the people together and figure out a design that works well, that's efficient, and is usable by the customer has been really fun.